positive integer, it can be expressed uniquely in the form n is equal to ak b to the power k plus a k minus 1 b to the power k minus 1 plus dot 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 up to a1 b plus a naught. Actually, this is very important representation of number. You can see here, if n is a positive integer, then it can be expressed uniquely in the form, and here b is a positive integer greater than 1. So now, where k is a non-negative integer, a naught, a1 up to dot dot ak are non-negative integers less than b, and ak not equal to 0. For example, if b equals 10, then 8, 5, 9 is represented by 8 into 10 to the power 2. This is basically decimal form. Here in the base of 10, 8 into 10 to the power 2 plus 5 into 10 to the power 1 plus 9 into 10 to the power 0. Same, we can represent b equals to 2 in the binary expansion like 10110 in base 2 is equal to 1 into 2 to the power 4 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1. So here we can represent, we are not using 0 because when 0 multiplied by 2 to the power 3 and 2 to the power 0, the result will be 0. So here we are using 1, 1, 1, and here the same as in the decimal form, we are just using the place of the digit, like here this is the unit digit, this is the 10, this is the 100, this is 1000. So here 1 is equal to 2 to the power 4 plus 1 equal to 2 to the power here 2. Same, 1 is equal to 2 to the power 1. So here we can see the representation of b equals 2 in the binary expansion. For example, b equals 16 in the hexadecimal expansion. We use the letter a to f to indicate numbers 10 to 15, like 3a0aof 16 is equal to 3 into 16 to the power 3 plus 10 into 16 to the power 2 plus 15 into 16 to the power 0, and this is equal to 14863 to the base 10. Here representations of integers. How can we construct the base b expansion of an integer n? First divide n by b to obtain a quotient q naught and remainder a naught, that is n equals b q naught plus a naught, where a naught is greater than equal to 0 and less than b. The remainder a naught is the rightmost digit in the base b expansion of n. Next divide q naught by b to obtain q naught equals b q1 plus a1, where a1 is greater than equal to 0 and less than b, and now a1 is the second digit from the right in the base b expansion of n. Continue this process until you obtain a quotient equal to 0. So we have to continue this method and we have to divide again and again and again until the quotient is not equal to 0.